In this video, we're going to look at the benefits and usage of storage account resources. Now, the good old storage account is one of the most critical types of resource we have in Azure. Not only will we use a storage account directly as part of our application architectures, our configurations, but it actually forms the basis of a lot of the other Azure services that we think offer far greater types of capability. When we look at what a storage account actually is, it has a lot of the same characteristics as other types of Azure resource. For example, it has a certain name and it lives within a resource group. Also, like most Azure resources, it lives within a specific region. Now, when we pick the region that we want for our storage account, we're going to want to consider, well, what is using that storage account? Is it being used by a certain compute resource? Is it maybe connecting to a type of database for maybe backups or some type of other storage? We'd want to have them close to each other, ideally the same region, to reduce the latency. That will then give us a better set of performance. So if we quickly jumped over and started to actually look at what happens when we create a storage account, we can see that the initial options are, well, yes, I have to pick that subscription, the resource group, and then I give it a name and I give it a region. So those are those core basic types of actions. And then we can see we have this concept of performance. Now, we saw here there were two different types of performance. And for our performance, very often we're going to pick the idea of standard. Now, when we use a standard performance type storage account, it's actually behind the scenes going to be a general purpose V2. This brings the best capabilities of some of the earlier types of storage accounts, such as general purpose V1, some of the basic Blob storage accounts, and it gives us a whole set of different types of service that we can leverage. Now, we can also pick the option here. Instead of standard, I can do premium. Now, as the name suggests, I'm going to pay more for the types of service that I use here. And whereas general purpose V2 offers many different types of service, with premium, it offers a single type of service. This could be block blob. It could be page blob. So both of these are blob. Or it can be files. So it's going to give me a higher performance when I pick this option. And it may also expose other types of functionality to me. And once again, if we jump over super quickly to this, we can see that right now, I've just picked standard and I don't really get any other choices. It's telling me it's going to be a general purpose V2 account. As soon as I pick premium, well, now I have to tell it, well, what type of service am I going to use here? And I can only use one of them within the premium. Do I want page blob, block blob, or file shares? So it's very important that I need to understand, well, what is the functionality I need and what is the performance I need that will drive, well, what is that performance tier I actually need to pick? Now, the next thing we're going to select is our redundancy option. Obviously, our storage is going to be very important. We're storing the state of our application, so it needs to be very resilient. So when we think of our redundancy, we have a number of different options. Now, this is easier if we break this down and we look at, well, really, what is a region? So I can think about, well, I've got a region 1. And behind the scenes, most regions are made up of availability zones. And in a certain subscription, I'll always see 3 availability zones. They have independent cooling, networking, power types of capabilities. So if I imagine, for example, I have 3 availability zones, and I pick the type of storage account that I want to have for its redundancy. Now, the first one I could pick, we'll call it locally redundant storage. Now, with locally redundant storage, there's always 3 copies of my data, but they're in the same building. They're in with the same cluster of the storage. So I could imagine, for example, they are all living within a certain building. So my redundancy is, well, if something happened to that building, my data is just not available to me. So the next option we can do, providing the region supports availability zones, is we have the option of doing ZRS. Now, there's still 3 copies of your data, but now those 3 copies of the data are spread over the 3 availability zones. So if I think from a redundancy perspective, now I've got resiliency from something happening to any individual structure, and my data, hey, I still have a nice safe copy of my data. And then we can move into the idea that Azure regions typically are paired. So there's a paired region. So this is its pair. I don't get to pick these. They are paired as part of the Azure structure. And they have sets of buildings over here as well. I'm just going to draw one. And now what I can do is we open up a new set of types of storage. So one of them would be GRS. Now with GRS, there's still 3 copies of my data within a certain facility in the primary site, but then that data is asynchronously replicated where there are 3 copies stored as well. So in this world with GRS, I have 3 in the original region and then 3 in the paired region. So in total, I have 6 copies of my data. Now, a variant on this is we can have GZRS, which, as the name suggests, is a combination of zone redundant storage. So I have my 3 copies in the primary region spread over the 3 availability zones, where it is then replicated again asynchronously. We always want asynchronous replication between regions because there's a distance. And if it was synchronous, I can't acknowledge the operation to the application that's performing the operation. There'd be a long delay, so it would really impact my performance. And then it's all stored in the same cluster on the other side. So it's not zone redundant in the paired region. So once again, there are 3 plus 3 copies of this. Now there is an option, and we'll see this if we jump over and actually look. Now right now, if we look at the type, it's premium. And when we look at premium, notice I only actually have LRS and ZRS. If I change it back to standard, well, now suddenly I have all of my options available. LRS, ZRS, GRS, and G and ZRS. If I pick any of the geo-redundant options, you then get this extra option available. And give me read access to data in that paired region. So I don't have to do this, but basically this then makes it kind of this read access option. So now what would happen if I select that, I optionally can say, hey, I want it to be read access to the copy. And then I get a separate endpoint, a secondary endpoint for my storage account where I can actually go and read. Now, that works for Blob, it works for queues, it works for tables. I do not get read access when I use the files service. And again, we're going to look at what all of these services are. Now, the other thing you probably noticed here is when it was the standard performance, I had all of these options available to me. So if I'm standard performance, I can do LRS, ZRS, GRS, GZRS. All of those are available. If I do premium, there is no geo-redundant option. I can only do LRS or ZRS. So I get a subset of those different options available depending on what I pick. Now, technically, and this is a more advanced concept, but if I needed to replicate data to the non-paired region, I want to be more specific, there is something called object level replication. And that for my blobs would let me replicate a particular container to a container in a different storage account, which could be another region. It doesn't matter, but that's a more advanced concept. That's not something you're going to need to actually understand, which is probably a nice thing. Okay, so those are the core, really the attributes, and there are more advanced attributes, but you don't need to know them as part of this exam. So once I've understand the redundancy and the performance, we then have different types of service available within our storage account. So if we now think of the different services that I can leverage, and we've touched on some of these already, but probably one of the biggest ones we're ever going to talk about is Blob, binary large object. Basically, any type of data I want to store. And there are different types of blob. The most popular one we're going to leverage is something called a block blob. And with a block blob, it's just stored in these multiple blocks, hence the name. It lives in a container. And while we, within the container, might see a file like structure, there is no structure in reality. Any folders we see are virtual. It just becomes part of the name of the blob we actually put in there. This means if we actually try and move blobs between these virtual folders, it's actually a copy and a delete operation. So it's fairly slow. There's no true option of that. So when we think of this block blob, it's actually what we call a flat namespace. There is no true hierarchy. Now, one of the options we get when we create our storage account is we can enable a hierarchical namespace. So this then becomes the Azure Data Lake Storage Gen 2. So this now gives me a hierarchical namespace. Now what that means is I get true directories, so I can actually truly move things around. I get this advanced type of ACL, access control list, permissionings. I can support different types of API. So that's an option I get when I actually go and create the storage account. Also, in addition to block, we have page. So I can have a page type of blob. This is very good for random types of access when I want to be able to perform that. And then we have append. So append, as the name suggests, that's very good when we want to go and add additional data. For example, if it was a log file, that would be a great use for that. Now, within block blobs, we also have a concept called access tiers. So within here, we have access tiers. And this is useful if you think about, I may have very different requirements in terms of storing my data and how often I actually want to interact with it. And so I can think about, I have these dimensions of the amount of data I want to store, so the capacity, and then the actual operations I'm performing against it. And so what these access tiers let me do for blob is, well, we have the idea of a hot tier. So with a hot tier, this is for data I want to store and access a lot. We then have the option of a cool tier. This is data that, hey, I'm interacting with, but it's less frequently. You then have the option of a cold tier, which is data I very infrequently need to access. But if I do need to access it, I need it there immediately to me. And then finally, we have this concept of, let's pick a new color for this, do there, an archive tier. And what's interesting about the archive tier, it's actually offline. I can't interact with that content if I just want to go and read the file. I would have to rehydrate it back into one of the other tiers. Now, if we jump over for a second let's go and look at some storage accounts we actually have. Within a single storage account, if I look at my containers, notice I have multiple containers, and then I could see a particular container. Notice we have access tier. And within that same container, I have some hot files. It's inferred because hot is the default. I have some cool files. I have some cold. And I have one in archive as well. And for any of the other tiers, so I could just go and look at one of these files. I could download the file. Notice I have access to it. I could open the file up. And when I've opened that file up, it's a picture of my dog sleeping. But if I try to do the same thing to a file that is archived, notice there is no option to download. The Blob is currently archived and cannot be downloaded. Rehydrate it. So I'd have to change the tier and bring it back into another tier so then I could access it. And one of the reasons we have all these tiers is if we were to look, for example, if we look at the price to store, this is the capacity. So premium is by far the most expensive. And then it gets cheaper from hot to cool to cold to archive. So super, super cheap by the time you get to archive. So I pay more the hotter the tier is. However, I pay less for the actual operations against it. So premium is really cheap. Hot is very cheap. Cool gets a bit more expensive. Cold is even more expensive. Archive, I then have to pay money to actually go and bring it back. And so I'm having this trade-off of, well, what is my anticipated interactions with the data versus, well, hey, maybe I just want to store it as cheaply as possible. So I pay the most for hot, but I pay the least for the operations. Whereas with archive, I pay the least for the storage, but I pay the most for the operations. And it obviously, it goes that route. So I would need to take a little bit of time to understand my usage patterns and how often I intend to interact with it. And then I could pick the right tier based on what is my anticipated use case. So again, cold is really good where I barely intend to ever interact with it. But if I do need to interact with it, I need it straight away. It could be medical records, for example. Archive is really good where I need to keep the data. There wouldn't be an immediate need to interact. I could wait 12 hours and I could just go and rehydrate it. So it's that balancing as part of that. Now, there are minimum times I have to keep the data in the tier. So for archive, I have to keep it for 180 days, or I pay an early deletion fee. Basically, I'd have to pay for the remaining time that I had it there minus 180. For the cold, I have to keep it there for 90 days. And for the cool, I have to keep it for 30 days. There is no minimum time for hot. So that's another thing to consider. Well, how long am I going to need that data for? I wouldn't want to go and put it in cold to save money, but then only need it there for a week. So I would consider that minimum time as well. I mentioned we had Page, which is very good for random access. And in the early days of Azure, the disks we would create for our virtual machines, we would store in Page blobs. But then I would have to worry about, well, the storage accounts, how many disks I could have within a storage account. And so what was introduced was the concept of a managed disk. So now we have this Azure resource called a disk, and behind the scenes, it is using Page blobs and it's abstracting away the storage accounts. I don't see them at all. And once again, as you would expect, there's different types of disk, and then I can pick a certain capacity. Now, when I think of the different types of disk that are available, they have different capabilities as well, and they have different latencies, i.e. the time a certain operation would take. So at the lowest level, you have a standard hard disk drive. So that's the cheapest, but it's also got the lowest performance and the highest latencies. Then you have a standard SSD. Then you have a premium SSD. Then they introduced a new type. Then they introduced a premium SSD v2. And then we have the concept of an ultra disk. So you have all of these different capabilities for these different types of disks. And for these disks, based on the capacity, the performance kind of scales linearly. As the bigger the capacity of the disk, well, the performance increases as well. For both the standard SSD and the premium SSD, there is a burst capability. So for a limited amount of time, you can actually get some higher performance than typically comes with the disk. For premium SSD, you can also set a different performance tier. This might be useful because if the performance scales with the size of the disk, imagine a scenario, I have a premium disk and it's a certain size, so I get a certain performance, but I need a higher performance. Now you might say, well, just make the disk bigger and then I would get a higher performance, but you can never shrink a disk. And so what this lets me do is I could change the performance of the disk higher for a period of time, and then I could shrink the performance again because I never resized the disk. With the premium SSD v2 and the Ultra, they actually have separate IOPS, input-output operations per second, and throughput from the capacity. And I can also dynamically change them, which means I could modify the values while the disk is being used by something. So I have this huge range of different capabilities and huge ranges of performance. So if I go and look at managed disks, well, here you can see the concept of, hey, look, a premium SSD. You can see, well, look, I get bursting. You can see I get this certain amount of burst capability over here. I get a certain number in brackets that I can burst to. It's for the smaller size disks. So I get this credit-based bursting. There's also premium SSD v2, where now the performance doesn't scale. So with these premium SSDs, the performance, notice this column, is going up as the size goes up. Well, on the premium SSD v2, it doesn't. I just pay a certain amount for the IOPS and I pay a certain amount for the throughput. Standard SSD, once again, let's pick a different region. Standard SSD, once again, performance goes up with the size. Also the standard hard disk drive. Price goes up for the size. Ultra disk, hey, I pay for the IOPS and the throughput. So the pricing is different depending on the type of disk. And what's kind of nice here, if I was to jump over and look at my disks for a second, and I just create one, you'll notice I get to pick down here in the bottom the size. And for the regular, here you can see it's a premium SSD. The performance changes based on the size. But notice it also shows me a performance tier. I could pick a higher performance than the size if I wanted the higher performance characteristics, but I don't want to make the actual disk bigger, because then again, I could shrink this in the future. Whereas if I pick a standard SSD, I don't have that performance option. Standard hard disk drive, again, don't get that option. But both premium SSD v2 and the Ultra disk, I just pick the capacity and then I pick the IOPS and the throughput I want. And once again, I could dynamically change those at any time. That's one of the very nice things. And again, the latencies get smaller here. So we get to sub-millisecond with the premium SSD V2 and the Ultra, and I think the Ultra is sub-half millisecond. So it's very, very low latencies when I start talking about those types of service. And disks are what we'll use with our compute services like virtual machines and Azure Kubernetes services. I don't want to deal with storage accounts behind the scenes. One of the other big types of service we get here is files. Now with files, we're offering a storage protocol. So typically this is going to be SMB, which we talk to very often from Windows clients, but it does also support NFS. Now, this is typically used by Linux, but for NFS, this has to be a premium performance tier. So I can't be general purpose V2. I would have had to say, hey, I want premium, and I would have picked files of the type, and then I can do this NFS set of capability. But basically, I'm creating these file shares that I can then go and connect to and leverage. For SMB, it can also integrate with Active Directory, so Kerberos-based authentication. And one of the really nice capabilities I can actually do here is consider, for example, I have my Azure cloud. So I'm in Azure. And I create an Azure file share. So now I've got a share. And this will be SMB. Well, now imagine I have on-premises. So now imagine I have on-premises and I have Windows file shares. I can use a technology called Azure Files Sync. And what this does is I have one cloud endpoint, and I think up to 100 server endpoints. And what this will actually do is via the file share, it will keep these all synchronized with each other. So I can have many file servers and they would synchronize via the Azure file share. So this might replace something like distributed file system replication. And an optional benefit here is imagine I had data that I didn't use very often on these file servers. Well, it could actually go and tier it off to the cloud. So this means it wouldn't store it on the file share anymore, but it would still have like a shortcut. So if I looked at the file share, I would see the data, but in reality, it's actually not storing it. And if I try to access it, it would re-download it, it would pull it down. So Azure File Sync can be a great solution when I have Windows file servers. I want to keep them synchronized, and I want the ability to offload data that I'm not accessing very often. Another capability, other services, we have queues. So a queue is a small piece of data that I would write in, and then something else would read it out. It's called FIFO, first in, first out, i.e. the first thing that I wrote to it when something tried to read would be the first thing out of it. And typically we're going to use this for event-driven workloads, i.e. something is going to write this item, and then something else, when it sees something written, will trigger some serverless function to pull it off and then do something with it. So that's a very common type of solution. Another thing we have is tables. So tables really is just key value data. There's no schema. It will look like almost like a database table, but there's no set schema. I can add any columns at any time. I only have to have a subset of the ones I actually want. This is not getting a huge amount of focus, nor is queues these days. Tables, Cosmos DB has richer functionality. Queues, there are other event type technologies that we would typically leverage. Another technology I guess I should mention over here is there are static websites. Now, really, static websites is building on top of Blob. What it actually does is it creates a special container called web. So this is just storing the files. It has to be static content. can't require server-side processing, and it will just make it very easy to go and serve that content up. If I have some HTML cascading style sheets, JavaScript in my pages, image files, I can just make that available super, super easy. So if we jumped over, if we go back and we looked at a storage account for a second, we actually have a very nice storage browser that's now built into the portal. So if I select this, well, I can see those blob containers again. So I can see my images exactly as we saw before. But additionally, I can see that $web folder I mentioned. So that would be my static website, where I would just put in the content. And then under my data management, I define that static website, like what is the home page, what is the error document, and it will just read it from that $web folder. And I can just go to this URL, which is based on my storage account name. It's not going to be very interesting at all, but there's my fascinating website that I was able to host just from a storage account. But also, if we jump back over and look at our storage browser, I could look at my file shares. So I've got file shares here, which I could go and access in a folder and see the information. I have queues. This is my test queue. So I could add a message. So it's now added. And if I dequeued a message, it will just pull off whatever that first message was. And likewise, I have tables. You can see I've added a few different attributes to this, but there is no schema here. I could go and create a completely new entity. I could add as many or as few of these as I wanted. I could add a brand new property at any time just for my particular entry I want, because it's just all key value pairs. So that's a really great capability that we have as part of this. The final thing I would mention actually comes back a lot to when I think about I have all these different tiers of capabilities. I may want to delete data. So one of the things to help us do this is we have something called Lifecycle management. Now, this is a free solution, and it's really just focused on moving data between tiers and deleting data. So it's really about optimizing our costs. So I could say, hey, based on the created date, the last modified, the access time, if it's not been accessed for so long, move it down to a tier. If it's not been accessed for 400 days, just delete it. So I can do that with the lifecycle management. It's free. It's a fairly simple. It has very limited, though, flexibility. I'm creating these on a per storage account. And then we also have a paid offering. The paid offering is something called storage tasks. They work at scale. So they can perform nearly any action. So I could also do things like, yes, I could move, but I could set data protection. I could set immutability rules. I can tag. I could undelete. It has full wildcards. So I could do wildcards. I could do question mark for single characters. And again, I create these centralized policies and actions that I then apply to different storage accounts. So it has way more scale capabilities. And again, I've got those wildcard supports. So at a high level, if I just wanted to optimize things and move stuff and delete stuff, I'll use the free lifecycle management. If I have a more complex data estate, if I have data sets I want to manage the cost, the data protection, the compliance, well, then I'll use storage tasks. So that was the very high level view when I think about storage accounts. So if you saw a question that was like, hey, I need storage to connect to my virtual machine or my Azure Kubernetes service, well, it's probably going to be a disk. I'm going to want to use my disk capabilities. I need to offer an SMB or an NFS file share. Oh, well, I'll use Azure Files for that. I need to synchronize content between my Windows file shares and the cloud. I want to synchronize them. Well, Azure File Sync. What capability would let me pay different amounts of money compared to the capacity and how often I'm interacting with it? Well, that would be my access tiers. So just have that base understanding. Also remember, again, the resiliency, the GRS and the GZRS give me copies in those paired regions. So now I'm redundant even from an entire regional level outage. Hope that helped. Thank you for watching.